Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of Robotics and Automation News.com. In this interview, I speak to Nimit Patel, president of Hydraulic Manifolds, a company which has supplied its technology to clients including Disney and NASA. The generic term hydraulic manifolds refers to one of the fundamental components of a machine that moves. It could be said that hydraulic manifolds and electrical control systems, or integrated circuits, are the two fundamental building blocks of any automated machine. In fact, hydraulic manifolds are increasingly resembling integrated circuits, as Nimit will explain in this presentation and interview.
This is Nimit Patel from Hydraulic Manifolds USA. What we do is essentially we are the leading manufacturers for hydraulic manifolds and valve assemblies. Hydraulic manifolds, for somebody who's not familiar with the product, it's essentially a hydraulic integrated circuit. Um, Essentially it's very much like a PC board circuitry in the electronics. Um, in the hydraulics world, the manifolds are instrumental and key component that makes the entire hydraulic system function. The manifolds essentially combined with the various valves perform the complete circuit of the entire manifold. And as somebody who has been up in the hydraulics industry would be kind of familiar to the manifolds and the valves, you would be able to identify them as the one of the heart of the entire hydraulics. This is Manifolds are typically custom designed, made to order. The biggest reason for them to be custom designed because it's a key element to the performance of the entire hydraulics. The the motors, the the pumps that do get connected with the valves and the manifold, uh, they basically have they exert pressures and the flow into the entire circuit. So whenever the manifold is being designed, it's important to know the pressures, ratings, the operating pressures, and the flow. So where do we play the role in this whole hydraulic manifolds making? We essentially make it from concept to completion. The customer comes to us with the raw sketch or the circuit of the manifold. We have been, by the way, we have been doing this since 1971. So we have almost 50 years of experience trying to take it from the concept level and deliver it to the end completion. When I talk about completion, it's not just about a machine component, but also about assembly and doing functional testings. So we have been a global supplier of manifold assemblies in every continent. Our products are out there, and for, of course, several years. Our manifolds, by and large, are guaranteed to function to the customer specs provided. If there are any issues with the workmanships, we are there to support it for the life of the product. Our products are everywhere from Disney World to NASA. Wherever you find hydraulics is essentially there will be a manifold. Typically, the manifolds are sitting right behind the big cylinders and assemblies. Up in every industrial equipment, there is hydraulics. of course, Disney World, all the recreational have hydraulics. For NASA and SpaceX, there's hydraulics in not just inside out, but also various simulation equipment to launching pads and all across. Our website kind of has a listing of the various industries where our products are found. Our business model, as I said, it is from concept to completion. Design engineering is our key discriminating factor compared to the rest of the other hydraulics manifold manufacturers. In addition, for us to be doing manufacturing and engineering, we also provide assemblies and functional testing, as I kind of mentioned earlier. Very few people up in the industry have ISO 9001 certification that covers the entire process workflow, right from the design, engineering, to all the way to assembly. So we definitely are more on the cutting edge and more up on the industry standards where we have been in compliance with the external entities. So far, we have more than, I would say, 14,000 designs of manifolds that we can count for. We have made more than 10 million manifolds. A lot of these manifolds can go from few pounds to few hundreds and even thousands of pounds. The big manifolds are typically used up in the various bridge applications, heavy industrial applications. Most every manifold includes some sort of foam tools. These foam tools are used to make the cavities inside the manifolds. In our library, we have more than 600 various different foam tools, which not very many people out there in the industry have it. So this kind of puts us more on a means why us? We essentially have the toolings and we also have the experience of using those and making those. Our products are less than 1% return on year after year, which basically shows to the quality of what we deliver. The business is family owned and operated, so we have accountability of each and every issues. The quality product and the customer service is something that we pride on. So one of the key things trying to take our audience into the hydraulic manifolds is why should or how is hydraulic manifolds different from others? So in the automation world, of course, we are talking about more and more automations as part of the process all across. Our product is used up in various automations, and also we have created processes and technologies around here that I would like to call it as close to the automation process as possible. So in our process queue, we are ISO 9001 certified, and our quality inspection yields less than 1% return. So we have a very robust process as part of the entire workflow that flows from order taking to the actual until the product gets shipped. The folks that makes part of the hydraulic manifolds, we have key individuals who have years of experience, and they're paired with young and technology innovative mindsets. So we have a good perspective in each and every department that basically provides not just the learner as well as but also the more innovative approach to what we do. From the technology side, we of course we have a specialized tool sets right from the designing to the makings of the manifolds. We have one of the leading software, which is very much utilized by Parker and Rexroth up in the industry, which allows us to design manifolds, ensuring all the industry standards are being met, from minimum thickness to the pressure ratings to ensuring how the break-ins needs to be up for the manifolds. In terms of the manufacturing side, we have high-speed machining centers with 1000 psi coolant, automatic tool changings with almost 180 tool sets, 180 and more. We have multi-pallet systems, carbide toolings, which also kind of allows us to become and remain more competitive up in the market space. Of course, the tooling kind of puts us also on a discriminating factor where we have 600 different form tools. We can make various cavities for pretty much every different kind of manufactured cavities out there. In terms of the capability offering, from circuit to the completion, we not just kind of take the circuit and design the manifold, but we also have the tool sets to review the circuits from some of the folks that we have in our team who have decades of experience reviewing the circuits to some of the circuit design tools that we have allows us to ensure the integrity of the circuit and the accuracy of the circuit is there. Of course, that sometimes is not all of it, so that's where the tool sets are combined with the human eyes to help us ensure to what customer needs and requirements are in complicit with the circuits that they provide. Now we use the engineering software that I mentioned earlier, MD Tools, Hydra. These are kind of more specially designed for the manifold manufacturing and circuit reviews. The material that we work on is all sorts of popular material, so we can make a manifold in whatever material the customer may have a need in. Currently, actually today, we are also making up in bronze, as I have it right here. So, from plating anodizing, we provide all the secondary operations for the finishing to the ASTM mill standards. In terms of the assemblies, the valves, fittings, we have it all. We work based off the order to how the customer would like us to fulfill it, and we can not only just again make the manifolds, but we can assemble them, we can do a functional testings and ensure that it is to the customer's needs. The quality assurance is important as part of manufacturing as a whole, and a lot of the times customer would like to kind of get an insight to what really do we do and how do we maintain quality. Of course, the ISO 9001 kind of provides assurance to the quality process. But in terms of what do we do to maintain the quality of the product and from the technical sides. So all of our designs, before we move it to the manufacturing, we send it out to the customer for review. Sometimes customer just signs off on it. Other times we have discussions leading to how really we came up with the design, to what really are the thought process, and if there are any concerns that a customer has, we try to capture them. We use zero leak plugs, which are patented plugs out there. We have a very great success rate of having no leaks, which is a very common concern up in the hydraulics industry. The quality packaging includes using flexible foam, Instapak foams with 5-ply packaging. So when we do kind of ship the products that we make, we have next to nothing in terms of damages while during shipping. The burrs are one of the very common concerns up in the industry, especially inside the hydraulics. If there is any burr, it has a potential for pump and motors and all sorts of failures, the heat, and of course the debris inside the hydraulic system. So as part of our quality process, we ensure that our products are burr-free and every piece is being inspected before it's being shipped. And this is majority of the issues kind of for every manufacturers is right here. So our team is utmost vigilant about ensuring that there is no burrs in any of the products that we ship. We have a multi-tiered inspection process to ensure the quality. Right from the stage when the product comes off the machine to until it's being shipped. So this is kind of allows us to provide a warranty onto the workmanship for our products. In terms of the new and emerging new capability offerings, we have been offering ultrasonic testings, pressure testings for the manifold assemblies. We have been leveraging new tool sets to collaborate with customers while we are trying to do design work and something that involves concept circuits to all the way to assemblies. Assemblies becomes a tricky part of the right from the design aspect, because we want to make sure that there is enough room for all serviceable parts to come out, and all the various plumbing that is being done, they go up appropriately. So when we try to do this assembly work, we try to make sure that all these things are being taken care of. Other times when we don't do it, the customer provides an input because they have a more visibility to how they're going to assemble it. We are, as we do the assembly for various valve manifolds, we have a close relationship with various cartridge valve manufacturers, and we can offer those discounted pricings and extend it out to our customer. So this becomes a key importance for various customers because it allows us to stay competitive and also be able to provide it for the best value for the customer. Outside our normal machining, there has been requirements, and we have been fulfilling some of the products around the manifolds and the assemblies and the hydraulics kind of industry, as they need various fittings and the various small components around, again, the entire assembly. So a lot of those components comes from the investment castings, as well as there are some fittings which are either standardized or there is some customization to that. We have been supporting those kind of requests on a need and ad hoc request basis, and we have been able to provide those products at a very competitive pricings. One thing I would like to mention as we are coming to a closure is hydraulic manifolds. Having been in industry for almost 50 years and having an experience making various cartridge valves, we also have an intense level of knowledge and experience in-house in making DIN cartridge valves. These are very tricky because of the high tolerance requirements, and not very many people out there are comfortable making these DIN cartridge valves inside the manifolds. So we have our team, and if a customer does have a need for any manifold requiring DIN cartridge, we can definitely support those needs. We have gotten involved with kind of design as well as the manufacturing of the power units, and on a request basis at times, although we haven't really spent too much time and it's not a primary business, we have supported up in parts and up in full in terms of some of our customers while their need has been for the power units. At last, here's our contact information. If you would like to check out our products or send us an email for any quote requests, or even if you would like to kind of, basically brainstorm with us about any of the product or the design needs that you have, feel free to reach out. Thank you. This is Nimit closing out.
Thank you very much, Nimit. That was an excellent presentation, very interesting. Although I must admit at this stage that this is a completely new subject to me. I mean, robotics and automation is also very new to me, but I've had a couple of years to learn a little bit. I don't know how much I've learned, but this is completely new. I looked at the individual words hydraulic and manifold, tried to understand what they are. The only time I've seen hydraulics is things like when I've gone to the gym, you have hydraulic weights and other places where you might have similar sort of mechanisms. And I wanted to ask you, because you're the expert, obviously, if you could explain what a hydraulic mechanism is, what it uses. Does it use compressed air or liquid? I mean, I can't see any liquid. I imagine there's air involved or something, but can you explain it in simple terms in a way that I can understand, please?
Sure. So hydraulics and pneumatics, you may have heard the terminology go kind of hand in hand. Whenever we are talking pneumatics, it's typically kind of air. Hydraulics has a big spectrum, is fluid. There is another term in technical words, it's called fluid power. Fluid would be anything liquid or air, any kind of gas medium, or even the liquid like oils. Uh, to the most common, whenever we are talking hydraulics, it's essentially the hydraulic oil. The reason hydraulic oil is so prevalent as the ideal fluid for the hydraulics is because of its having its compressibility and being able to transfer a greater amount of energy from one place to another.
Why, what kind of, is it a special kind of hydraulic oil? You called it hydraulic oil. Is it a specific type of oil?
So when you, if a one hydraulic oils comes up in various grades, some of them are more with various viscosity. So from something which is of, and then every viscosity has, basically its own properties, which again allows how much of a heat that it would basically kind of absorb and transfer away to how much of a pressure it will take. So all the oil matters, as just like in the engine oils in an automobile. Over time, the oil is going to break down, and it will kind of lead to in the automobile world. It's a common thing to say, okay, you need to do a routine oil change to enhance the performance of your engine. So that's basically the compressibility of the engine and to keep the pistons moving. So that's I think a very good kind of example that's of the everyday in the auto industry that we see in terms of how the oil is importance of the hydraulic oil. The engine oil is of course one of them, but then also in the various other applications, there are hydraulic jacks oil. There is some of the other various grades, and all those grades again are being kind of picked based off the not just they of course vary from pricings, but based off the mechanical properties and the physical properties as needed for the particular application.
Right. And then manifolds, the other part of your company's name. I looked at lots of pictures of manifolds, and I mean, I don't have an engineering background, so I don't really know how they work. They look very complicated. I know it's essentially on the outside, it's a piece of metal with holes in it, but it does, even to me, I can kind of imagine how complex the thing is. But let me, rather than ask you to explain the technical details, which I probably wouldn't understand, I was wondering if you could give me an example of how a hydraulic manifold would be used in, you mentioned a car, but how about industrial robotic arm? Do they use hydraulic manifolds inside them, and where would they be?
The hydraulic manifolds would basically, I guess I would like to kind of first, go back to the terminology that I mentioned, the hydraulic integrated circuit. So if you are able to see my screen, the inside of the manifold basically looks like all their connections made from one hole to another.
It's a very good
So this
picture
is
you found. Yeah, I like it.
right. So this is the what the inside of the manifold looks like. So if you are familiar, or if anybody is familiar with the electronics world of PC board, so essentially the fabrication of the PC board is done where it's been identified where a capacitor would go, where a resistor would go, and where all the electronic components are going to be assembled to make the entire circuit. But before those products are assembled, the PC board is being fabricated, which essentially is nothing more than all the wires that are being connected. But this is now done in a more compact way in a small circuit. So this is very much the same, that you can essentially take various valves. The classic approach would have been to take the pipes and hoses and connect it from one valve to another. Of course, now the industry has revolutionized, where a lot of these valves are more like cartridge screw-in valves, which very much looks like this, and then they would assemble inside the manifold, and this compact design will deliver the entire circuit to what a person would like to for the desired application.
Now, where would I try to find pictures like that? That's it's really good that you found that. But where I couldn't find a picture of where it would be located inside a machine. I tried to find a car
Sure.
with which showed a manifold inside it, but I couldn't. I'm asking you about an industrial robotic arm, but you can give me any example of a machine, and where would it be located, and kind of what kind of
So
thing
in the
would it do?
right nowadays, every industrial automation machineries, there are two things that makes up for the whole. One is the hydraulics, and other is the electronics and controls. So controls, electronics is of course how the low signal or the power is being delivered. All those power is basically delivered to the valves like these, which is basically how it operates, the signal that it receives. The controls would be the brains that will essentially say, okay, what and how the various automation needs to be performed. But the actual mechanics of the automation is performed by the hydraulics. So as there are things like actuators, cylinders, pistons, which basically perform the work is performed by the mechanical arms. Behind those mechanical, what should I call it, the mechanical components that delivers the work, there would be a manifold essentially combined with the valve. The entire valve assembly is how the entire mechanics is taking place to deliver the energy and the force to do the work.
And typically, how many manifolds would be inside a machine, like, for example, a car or a robot? There can't be just one. There's got to be quite a few of them, I imagine.
True, it could be one, two, very many. So depending on the design and the applications, sometimes there are a couple of them, these up in a one big application, and sometimes it could be truly like, this is a medium size to sometimes it could be very big. Like this one is a very big one that would go up for a high-end application.
Yeah, you mentioned
So,
about.
and this manifold could be like over 1,000 pounds.
Yeah, I mean, that's the sort of thing that maybe you would be using on a bridge or some other big structure or
Correct.
machine.
Correct.
Yeah, I'm beginning to understand a little bit better. Yeah, so the company itself and the technology itself. I mean, as I say, it's new to me, so I may be asking some very basic questions. I've never seen a picture like that where it looks like an integrated circuit in the way that you describe it. I can understand the parallel or comparison that you draw. Um, is that something that, in some way, that you've pioneered? Your company, you say that you're first in some ways. Is there something that your company has done that's different, that brought the technology forward or made progress? You've certainly got some very high-end clients. I think you said Disney and, was it NASA or something? I can't remember now. But
Correct. SpaceX, NASA, and then the various other kind of farming industrial applications, from caterpillars to other ones.
yeah, what would you say are some of the innovative things you're doing? I didn't understand the DIN cartridge valves that you mentioned. I don't know what DIN means, but what are the innovations that you can highlight about your technology, hydraulic manifolds?
So the manifolds has been in the industry for years and years, as part of the hydraulics. The innovation that now it has came to is trying to do more compact design. There is more and more mobile applications, and this is where automation and the robotics comes into place. So there is a big constraint in terms of not just kind of make the entire hydraulic systems, but make it more lightweight, that is very portable, and that kind of gets transported with things like the robotics and the various automations. So I think we are challenged in the recent times with designing manifolds in a more most compact design, and there is that time being spent to create the most optimized designs and even take off the weight off of the manifold is becoming more and more in demand out there. Also, the pressures are becoming, some of the application require higher pressure. So this is where we are being challenged, try to just not make a manifold up in regular aluminum 6061, but then also ensuring that we have the capabilities to manufacture manifolds for high-end marine applications, for something which is going to be inside water for a long period of time. So that's where we use stainless steels, and we use other materials which are, of course, more challenging, to manufacture, but those are in need and in demand by the customers on a routine basis.
Yeah, you mentioned some of the materials that you use. That's quite interesting. I don't know if I should ask this, but it's a question I came to mind about the responsiveness of a robot, how quickly it can respond to its environment. I would imagine the lighter the material, the faster it can respond to electrical signals, whether picked up through sensors about its environment or
Correct.
collision avoidance and things like that. So is there materials that you find interesting? You mentioned steel and brass and things that are relatively well, I suppose the manifold doesn't have to be light. It's the parts of the robot or machine that have to be light in order to for it to move faster, I suppose. But yeah, what is that an issue that you've come across
The
or something that you've talked about before?
Sure. The lot of the robotics as well as the aerospace industries, which basically are more about lightweight and higher performance. The material 7075 in aluminum, which is kind of as light as an aluminum, but also has the strength and the power of a steel, which is of course it's more than twice times. Of aluminum is typically rated for less than 3000 psi, while any application requiring more than 3000 psi, we try to manufacture those products up in ductile iron or steels. Um, Anything requiring kind of much higher pressure, there are some of these grades out here. I can probably spend more time trying to explain, but to kind of give you a more shorter version, various steels, various, these 4140s are of course more used up in the high-end applications for oil and gas industries where they're trying to do fracturings and they're trying to go even beyond up to like 15, 20,000 psi's. So there is, of course, some of these materials right here where the weight is not a concern, but then the pressure ratings have to be much higher and desirable. But typically up in the mobile applications and robotics and aerospace, 7075 has been a more common material of choice for the customers.
Yeah, very interesting. And what kind of customers do you supply plastic manifolds to?
Plastics are more for the pneumatic applications and also for test R&D type work activities, where they can also for the demo and for exhibition purposes. So they're very, I should call it, other than pneumatic applications, these things are not kind of so much of what should I call it, resilient to high pressure or for a production environment.
Right. And correct me if I'm wrong or explain to me better than maybe I understand what I'm going to ask you. Hydraulic manifolds are essentially involved in the actuation of a machine like a robot or car or anything that moves. Actuation meaning actualizing some sort of movement, I suppose. Maybe you can explain better. But what I wanted to ask you is, hydraulic manifolds is a part of an actuation system. Is there, as a technology, is there another or are there other types of technologies and systems that are alternatives to hydraulic manifolds? Or are hydraulic manifolds the only way to actuate or to achieve actuation in the machine?
So without the manifold, I would say, means basically uh, the use of the cartridge valves out there is becoming, it's the most prevalent um, cartridge valves. Um, so use of these cartridge valves is the most prevalent way of functioning hydraulics. Now these valves to introduce to you are basically some of them kind of takes the oil, reduces the pressure. Other than other, some of them they basically try to redirect the flow. So this is where the brain cells of the entire hydraulics kind of comes into place. Of course, these valves, many of them are mechanical other than are electronic based. So depending on the controls and the signals, they kind of also go up or down, or they function, or they kind of dictate how the fluid flows. Now, for all of these valve application, they would not function just like this. They only function in combination with the valve, with the manifolds. This is the most kind of, what should I call it? It's there is not really an other alternative way to do this type of meeting the end results. Um, if you kind of because in alternate to these valves, there were some of them were more like a, what should I call it, like a regular these kind of manual operated valves up in the old days, but this is of course more labor intensive process where they only do is like open and close. So there is not much of the intelligence built around these type of a classic approaches of valves. So this is very, very, very old school, and nowadays more and more robustness. Even before the robotics kind of decade that started, is this cartridge square valves have been around for now. I would say for a couple of decades.
All right, thank you very much for that. And finally, could you tell us a bit more about your company? Just basic information, like I don't know how many employees in total, anything that you can share in terms of financial data, perhaps turnover, and what's the kind of business plan or ideas going forward in the next year or so? How do you see the future for the company?
Sure. Um, in the last 50 years, our business have went through the ups and downs of the hydraulic industry. And of course, we are still here and not just surviving but prospering. In the last recent years, we have grown our team. We are somewhere between 20 to 50 people. Depending on the type of work, we are oftentimes are more onto the hiring spree. And some of the folks, of course, over the time who has worked here for several decades, have retired, and then they will be retiring up in the upcoming years. So this is where our biggest a process change or the industry challenge that I would say is how to really ensure the continuity of operations while some of the folks that are out there for several decades as they retire. How do we ensure the quality of the product that we manufacture and we deliver to our customer, it stays and remains. Um, so that's kind of where our ISO 9001 comes into place, and we have developed a process inside where we have a learning process for the folks who are not here for very many years in the industry and also in the manufacturing. They kind of work in close in closeness with folks who have decades of experience. In terms of the financials, means we do business up to like $5 million a year. We have been doing manifolds and the various assemblies. There are some of them out there who do kind of even more than us, but we have tried to kind of keep it in a way which is we want to ensure the customer service and the quality that we deliver is in exceeding with when compared to the other manufacturers. So we have been organically growing, over the time, and we do plan in the upcoming years to slowly and steadily kind of grow to be able to do more and deliver more to our customers. I think that
Well,
kind of answers all your questions, right?
yeah, that's really quite complete. Thank you very much, Nimit. I really enjoyed that interview.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.